even if you know how to do it. All right, so here's a nice little application then of derivatives. It says f of x is equal to x to the fourth divided by 2. Find each of the following. So we need to find f prime and negative 1. So that translates to what on the graph of f of x? Like from the Leibnizian perspective, what are we finding? The slope of the tangent line, right, at negative 1, which is also the instantaneous rate of change. So before we can find f prime and negative 1, unless you want to use the modified or alternate form, the power rule will allow us to find f prime of what? X, right, the variable x. N? Did you say n? X. All right, so before we do the f prime of x, though, we need to write f of x in the power rule format. So that's 1/2 times x to the fourth. All right, so that is f of x. This is going to be, graphically, this is your y value machine. If you think of a function as a machine, that's your y value machine. We've had that since algebra 2. Now we'll take the derivative of both sides and we get f prime of x. What would be the derivative of 1/2 x to the fourth? 4 times 1/2 to get our new x coefficient would be 2. And then we deplete the exponent by 1. So 2x cubed. We are done with the derivative before the other person using the Newtonian quotient, as I called it earlier, the limit definition, is even done setting up the limit. And then they're going to have to expand a fourth degree polynomial. We're done. Multiply, subtract. This gives you your slope machine. It gives you the slope of that graph for the instantaneous rate of change. So now that I have f prime of x, now I can find f prime and negative 1. So we always find the derivative function first. And now I plug in and I get negative 1 cubed. And so, of course, then that equals negative 2. So that function is doing what at that ordered pair, or at x equals negative 1? Increasing or decreasing? Decreasing, right? Because the tangent line is negative, we know that the function is going downhill. We know it's going down 2 for every 1 it's going to the right. F prime is 0. Well, now that we have f prime of x, we'll just show it. F prime of 0 is 2 times 0 cubed, which of course is 0. What type of tangent line does that give us? If the slope is 0? Horizontal, yeah. So we have a horizontal tangent line. Those are going to be very, very important moving forward. As we talked about in 2.1, finding max-mins was a very important impetus for discovering calculus. We could have set it equal to 0 and solved for x. The x-coordinate where the slope has a 128. All right, so as I just mentioned, we can use the derivative, which was 2x cubed, as a formula, right? There's 2 inputs, f prime, the slope, and x. So we can either plug x in and find the slope, or we can plug in for the slope and find x. That's what we're doing here. So for a question like this is what you're going to want to show. You want to always show the equation you're solving. The equation you're solving. Because on a free response, that's going to be a check. And now it's just algebra. If we divide through by 2, half of 128 is 64. And you can take the cube root of both sides, or you can just raise both sides to the reciprocal power. And on a free response, either one of those would be an answer, but the cube root looked kind of gross. Let me rewrite it. The cube root of 64. Okay, so you can leave it like that on a free response. But for a multiple choice answer, neither one of those would be the answer choice because the cube root of 64 is what? 4, right? 4. 4 times 4 is 16, and 16 times 4 is 64. So I know at x equals 4, that function has a slope of 128. All right, now for what it's worth, let's go ahead and sketch f of x. The parent function is x to the fourth. The 1/2 is just going to be a vertical, what, by a factor of 1/2. If there's a 1/2 in front, it's a vertical compression. Good, we're just reviewing here. Vertical compression by a factor of. Mr. Peck came down the hall and asked me, we were clarifying this earlier too, because textbooks in the past used to not do it correctly, but now we would say by a factor of not 1/2, but by a factor of 2, right? Old books used to say vertical compression by a factor of 1/2, and that's not true. The compression means smaller. It's twice as small because it's half as tall. Half as tall or twice as short, I guess, would be the way to say it. Okay, so it's going to look like that. And what we did is we found the slope over here. Let's just call that 4. That was the slope of 128, so on and so forth. And then we could see at 0 there's a horizontal tangent line. And then we found it at -1, which would have been right around here, and it was a little flatter. So that's what we just found. Okay, so we did it all graphically without needing the graph. I mean, we did it all analytically without needing the graph. All right, example 4, kind of the same thing, another multiple step question, free response style. F of x is 3x squared. Find the equation of the tangent line at x equals -2. Okay, so here's a question now where you need to kind of map out a strategy. You're going to have questions like this a lot where you have to figure out what to do first, because a lot of people are like, I know what to do when I'm working, but I don't know how to start, right? So think about you're making like a bouquet of flowers, right? You need to go out and gather your posies and your baby's breath and your ribbons or whatever first, and then you can bring it all together and assemble it. Kind of the same thing here. Work backwards. Start with the end in mind. You ever work one of those maze puzzles from the inside out? It's really hard. But if you work it from the outside in, a lot easier. And some people call that cheating, but oh well. So what do we need for the equation of a line? That's what we're going to be walking away with. Well, we need a what for the equation of a line? Here's the form that we're going to be using all year long. So for the equation of a line, we need a point, right? We need a point, x sub 1, y sub 1, and we need a slope, okay, m. So we need a point and a slope, or a slope and a point. That's what we need. What do we need for the equation of a line? We need a point and a slope. We don't have either just yet. We just have a location, an x location. So let's go ahead and find the y value first. Let's find the point. The point is going to be -2 comma f of -2, which of course we can find to be, what is f of -2? The y value machine is f of x, remember? 12. Okay, good. Some people, as we go throughout the year, they keep forgetting that f of x is still the y value machine as it's always been. So you plug your -2 in there and you get 12. So there's the point. And now we need the slope. The slope is going to be f prime of -2. But before we can find f prime of -2, we need to find f prime of x. So let's do that up here. F prime of x would be multiply and subtract, and we get what? 6x. Cool. All right. So now coming back down here, f of -2 is going to be -12. So make sure that you're always labeling things here. All right, so now we'll write the equation. And because I'm presenting it kind of in this field where there's a lot going on, I'm going to mark it. Equation kind of signifies what I'm doing. And in Taylor form, we get y equals the y value of 12. And then it's always plus the slope, which now makes it minus, because we're adding a -12, times x minus the x value, which makes it x what? Plus 2. Good. And there's no need to go any further than that unless the answer choices on a multiple choice question have it in a different form. Okay, if it just says write the equation of a line, just drop it in and get out of there. All right, so now for the equation of a normal line at x equals 2, we still need a point and a slope. Well, the point is the same. It's still -212. But now our slope is not the same. What is our slope? Positive 112. Good. We had this on our last test. If the tangent line slope is -12, then the perpendicular slope is the opposite reciprocal. And that did get a few people. Okay, you could put m subscript perpendicular or m sub n if you want for normal. It's the opposite reciprocal. Change the signs and flip it. So then the equation of the normal line is y equals still the y value 12, but now plus 1/12 times x plus 2. And you will get a different y-intercept. Some people, it could ask you for the y-intercept of the normal line, in which case you could distribute. You do get a different y-intercept when you distribute the -12 versus the 1/12 and then combine your two constants. So it's not just the slope that changes in slope-intercept form. But in Taylor form, literally the slope is the only thing that differs between the two versions. Okay? Which is why Taylor form is really nice. We already solved for y. Find the points where the normal line intersects the graph of 3x squared. What the? Okay. Now it's time for a visual. We've been doing this all by instrumentation only. Let's draw 3x squared. That is your smiling parabola. It opens up, looks something like that. Y equals 3x squared. And of course, everyone can tell that that is 3 times steeper than a regular x squared graph. Good. That's the criteria. Oh, no. Okay. So now let's go ahead and go to the point we've been talking about, negative 2 comma 12. I'm just going to call that right here. There's negative 2, and I guess we'll just say that that right there is 12. All right, so the tangent line is going to look like this. There you go. Just glances right off and kisses it at that single point, right? The normal line then is going to be perpendicular to that, so it just comes in there and crosses through there at a right angle. Let me move. Ooh. Apple Pencil's getting a mind of its own. Retest tomorrow in class, what? Okay, no, that doesn't pertain to y'all. I guess I pasted something. I was trying to move that. There we go. Bull in a china cabinet. That's what my daughter says about me. All right, so there it is. There it is. So this question is saying find the points now where the normal line, which I have drawn in beefy brown, perpendicular to the purple tangent line, where it intersects the graph of 3x squared. So there's another place over here that I'm looking for, x, y. I already know one of the points of intersection, don't I? Yeah, it's the same as the tangent line point of tangency, we call it. Negative 212 is one of them. And then the other one is going to be, I do know the coordinates. Like if this were a multiple choice question, is the x value going to be bigger than 2 or less than 2? Should be bigger than 2, right? By the symmetry of the graph, I know the line has a positive slope, so it's going to be further out than 2. So 3, 4 maybe, I don't know. And the y value should be bigger than 12. You can kind of tell that visually. So with that and that alone, you might be able to get down to maybe 1 or 2 answer choices. By the way, the AP exam only has 4 answer choices, A, B, C, and D. I don't know if you noticed on your last test, you had a couple of them that only had 4 answer choices. I still like to put 5 throughout the year because it gives me a chance to deceive you one more time. But on the actual AP exam, they drop down to 4. So how are we going to go ahead and find where those two intersect? How do we find where two graphs intersect? Think back to set what equal to each other? The graphs? Yeah, their equations. Good. Yeah, we set their equations equal to each other. So let's go ahead and do that. The equation of the parabola, which I'll use color coding here, is 3x squared. And I want to set that equal to the equation of the normal line, which I just wrote up above, 12 plus 1/12 times x plus 2. This, by the way, makes a great free response question. Wink, wink, hint, hint, wink, wink, wink. Okay, so you're going to get a check for the setup. Remember, you always want to show the equation that you're solving. If you want to even be more explicit here, you could call this intersect or intersection. Okay, there's nothing saying you have to do that, but remember the free response or short answer is all about effectively communicating in the language of math how you got your results. So, you know, if you put kind of like stage directions or labels, it's good. All right, so what would you do first in Algebra 2 if you were solving this puppy? You would distribute the 1/12, okay? I'm going to go ahead and let you do that because that's one way to do it. Embrace the fractions and work with the fractions. And if you love fractions, you probably want to do that. If you're horrible with fractions, you probably also want to do that so you can get practice, okay? Right, you could do that as well. You can eradicate the fractions. You're like, I know how to work with fractions. I don't need the extra practice. I'm going to try to be efficient as well as effective. Because you have a fraction, I would multiply both sides by the LCM, which is 12. Again, it's not the only way to do this, but it's the way that I would recommend, okay? So 12 times 3 on this side, that's 36x squared. Notice I have parentheses around the entire right side. We are going to have to distribute that now. So 12 times 12 is 144. And then plus, here's where we just multiply the 12 times the 1/12, and those divide out to give us a what? A 1. Now, you do got to be careful. There's a plus sign there, so we're left with the plus 1. If that had been minus, you would still need to distribute that negative. So that's a common mistake. But right now, we're just distributing a positive 1, so we're just left with 1x plus 2. If it were a negative minus, you could multiply both sides by negative 12 if you wanted. But that's a careless mistake where some people go wrong. All right, so now I have a squared term, a non-squared term, and a constant. How do we solve those dudes? Get everything on one side, set it equal to 0. Yeah, so I'm going to have 36x squared minus x, and that becomes minus 146, and it equals 0. And now that I have a quadratic in standard form ABC, I can either factor it, I could do guess and check, oh my gosh, I could use the quadratic formula, I can complete the square and extract square roots, I can Google it with Wolfram Alpha, all kinds of ways, right? I can pray about it and hope that it comes to me in a dream, like the benzene ring configuration came to Kekulé. That's kind of rare that that happens, but it did. Any ideas? Let's try to factor it. Right? These are the fun varieties, where the leading coefficient is not 1. Oh boy. We're looking for combinations of factors of 36 and 146 that add up to negative 1. Well, how many factors of 36 are there? Probably not that many, right? 1 and 36, 2 and 18, 3 and 12. Holy moly, there's a lot. What? Muy bien, sí. ¿Por qué? Why? We already know one of the factors. Because we already know one of the solutions. There you go. Pay attention to everything you're doing, right? There's 2 solutions. It's a quadratic. We already know one of the solutions is negative 2. That's a point of intersection. So if negative 2 is a root, then x minus negative 2, or as Joy said, x plus 2 is one of the factors. There you go. And now it's not as difficult as it seems. We just have to force the other factor. If it needs to be a 36x squared and we have a 1x, this must be a 36x. And if the last one needs to be a negative 146 and we have a positive 2, this needs to be a negative 73. Yeah. And now all we really got to do is just check the middle term to make sure we get a negative 1. The inside gives us positive 72x. The outside gives us negative 73x, which when you add them together gets you negative 1. Well done. Okay? So that is the factorization. And now you can go x equals negative 2 or x equals, if you can solve that in your head, 73/36. So let's answer the question. The points of intersection are negative 2, 12, and positive 73/36, how do I find the y value? I can either plug it back into the equation of the parabola, 3x squared, or I could plug it back into the equation of the normal line. Which one looks easier? Probably the parabola one. So I'm just going to say 3 times x squared. And I'm going to leave it like that. Is that okay? If this were a free response question, would that answer work? Absolutely. It's going to be some number. There you go. So that makes a real good question for a free response. In fact, if you look at the test that's over the next section that are posted online, that is the last question on several of those. So make sure you know how to do that. All right, cool. Good insight, Joy, good insight. Use what you already know to help you do something you're trying to accomplish. Any comments or questions on that? So multiple steps problems, begin with the end in mind. I needed a point, I needed a slope, so I went out and got them, and then I brought them back, and then I assembled them in my beautiful floral bouquet, which was the equation of the line. Okay, so as you already know, rewriting an expression or a function is very important when using the power rule. We have to sometimes manipulate it so that it's in the form y equals a times x to the n. It's worth repeating. Rewriting is very important. So let's do example 6 now. Kind of the same thing, but now the instructions are a little bit different. It just says evaluate. So this is the verb format. What we just did previously was the noun format. Example 2, that was the noun format. Here's the function, find its derivative. Example 6 is just like evaluate. So how would we read that? The derivative with respect to x of that expression, or the derivative of that expression with respect to x. With respect to x is an adverbial clause, so you can put it kind of anywhere in the sentence. But x is our independent variable. I want to take the derivative of that. Do I need to rewrite that? Yeah. Now, in verb form, when you rewrite it, since ddx is already there, you have to keep bringing down the ddx. So that's going to be 5 halves times x to the what power? Negative square root of 2. Great. And notice the ddx is still there. So that's kind of a little bit more writing than just like y equals when you're rewriting a function. And now I'll evaluate it using the derivative. So when we take the derivative, the ddx goes away. So we multiply and subtract. So we get negative 5 square root of 2 over 2 times x to the negative square root of 2 minus 1's power. And the ddx goes away. Here's why the ddx goes away. I'll plant this seed right now. This is something called the chain rule later on. We multiply then by the derivative of that variable with respect to x also. But what is dx divided by dx, do you think? It's 1, okay? So that's why the derivative ddx goes away. That's coming in later. So there is the derivative. We're essentially done. We should practice, though, putting it back into a usable format. So that's going to be negative 5 square root of 2, build a shelf, all over 2. And again, that negative can go in the top or the bottom or out front to the side. If it's only one term, I just like to put it in the top. If you put it off to the side, sometimes in haste, you can put it like too close, and it looks like it's part of the division bar. You put it too far away, and it's like, right? So I don't know. There's kind of a distance that is acceptable, you know? So what is it? I don't know. But this is good, right? Don't poke the 5. There we go. Okay, right there. And now the bottom is going to be x to the square root of 2 plus 1. Yeah, just like with the pi thing. If you have multiple terms, you change the sign of both of them. So not a real pretty expression. I'm choosing ugly things deliberately just to get you practice. It could be with any numbers as long as they're real, which is what we're working with. All right, go ahead and do this one. No. It's a little bit different. It's not a function like y equals. It's just evaluate this expression. So we just work straight down. There's no equal signs. And the bottom line is considered your answer. Once you take the derivative, the ddx goes away. You'll hear me say this kind of a lot. Simplify early and often. Simplify in the beginning, try to manipulate it, and then as you go, try to keep simplifying as you go. It saves a lot of work on the back end if you keep it simplified as you go. So simplify early and often, math people. Vote early and often, the corrupt Chicago political machine, right? Even if you're dead, they want you to vote early and often in the same election. Ballot box stuffing, right? But anyway, that's not, Chicago's not as corrupt politically anymore, right? Okay, so anyway. That was their motto, vote early and often. We'll get rid of that. Okay, so what could you do here before you start? Well, you've got a quantity that's raised to the third power. So I would just simplify the denominator first. 2x quantity cubed is 2 cubed x cubed, which is really what? 8x cubed, yeah. And now, without those parentheses there, the 4 eighths can become a 1/2, and then I could bring the x to the top and call it x to the negative third. So notice I took 2 lines to rewrite that one, and so every line I have to put the ddx. You'll lose points if you don't have the ddx. Now when we take the derivative, we multiply and get negative 3/2 x to the negative fourth. When you take the derivative, when you use the power rule, that's where the ddx goes away. So there's one version of the answer, and of course you clean it up. Negative 3 over 2x to the fourth power is the cleaned up version. All right, so simplify early and often. There's a worksheet for this. You have enough to get going with it. Maybe we should quiz tomorrow, right? Just real quick, easy power rule stuff. Be an easy 100 for everybody. All right, we'll stop there and we'll pick up tomorrow. Don't forget, fill out your FAFSA.